Okay, so now we're going to look at an introduction to calculus. So calculus is basically the mathematics of change, which means things are now constantly changing. So we've looked at all different kinds of problems in which change is constant, like maybe we're adding the same amount of books to a book bag every day. That's a constant change. In calculus, we're going to look at something that is always moving. So maybe you're running, but you're running at different speeds the whole time. When you drive on a highway, you're constantly changing speed. So that's a big difference. So this year, the two main things we're going to be doing are the tangent line problem and the area problem. So the whole first half of the year is going to be all about the tangent line, and then the whole second half of the year is all going to be about the area problem. So before this year, we've always looked at a secant line, and a secant line is just a line that crosses at 2 points. So if this is the curve that we're looking at, we can draw the secant line, and we can find the slope of that secant line. That slope is our average rate of change, and this is going to come up a lot throughout the course. Average rate of change is just a slope. That's all it is. You know how to do that? We've done that since, I don't know, probably middle school. So just a reminder of how to do that. Remember slope, we find the change in y over the change in x, or change just means we subtract the 2. That's all that means. So if they ask me to find the average rate of change, that means we're finding the slope. This is an interval, meaning these are both x values, and I need their corresponding y values. So I have to plug them into this function in order to find those. So f of 2, if I plug that in, I'll get 4 plus 1. And if I plug in 4, I'll get 16 plus 1. And now to find the slope, again, I'm going to find the difference in the y's over the differences in the x's. So if I subtract these two y values, I'll get 17 minus 5. And if I then subtract the two x values, I'll have 4 minus 2, or 12 divided by 2, which is 6. This is the average amount of change for this quadratic equation from 2 to 4. Okay? We can extend this to working with variables only. So a lot of the ugly symbols you're going to see in this course, they mean very simple things. So if we were to look at this as this being x, if I increase that by just a very, very little bit, again, we're going to use delta. Delta means some small change. So if I increase it, I'm starting with x, and I'm increasing it by just a little bit. So that guy's going to be called x plus delta x. When I plug something into a function, its y value becomes f of x. So in this case, I'm plugging in this entire thing. So his y value becomes f of x plus delta x. And so now I essentially have two ordered pairs. The ordered pair for this point has an x coordinate of x and a y coordinate of f of x. And the second ordered pair has an x coordinate of x plus delta x and a y coordinate of f of x plus delta x. So these are two ordered pairs. If you were asked to find the slope between the two, you would take one y value minus the second. So we're going to take f of x plus delta x minus f of x. And then in the denominator, we're going to take x minus the second x value. So x plus delta x minus the original x value. If we clean up the denominator just a little bit, these can cancel. And we see that this ugly looking formula that you probably saw at the end of pre-calculus is just a really, really confusing version of slope. That's all it is. This is a y value. I'm taking y minus y. And x minus x is what we get when we subtract two x's. That's what delta x means. So when we see this throughout the course, just know this is the slope. That's all it is. So what we're going to be doing, and I'm going to pull up a video here to get this to make a little bit more sense, but we're going to be using the concept of a limit, which we'll learn in the first chapter, to turn the secant line, which is what we already know, into a tangent line. So what I have here opened up on Desmos is a quadratic function, and I have a secant line. I could find the slope between them. Right now, I'm using h to tell me how far apart these are. So this is like my delta x. That just says if I were to calculate the distance between one x value and my second x value, this is a distance of 2.72. This gives me my average rate of change. So like if I was driving on the highway and I wanted my average speed, I could calculate my average speed, but my speed is actually fluctuating the whole time. So if I wanted to make this more accurate and find an exact speed or an exact slope, an exact rate of change, I can take the green dot and move it closer to the purple. And what happens is this distance between them gets closer and closer to 0. So if you watch while I drag the green point, the distance between them gets closer and closer to 0. Now, remember, we're finding slope here, okay? The slope does not exist if there is no distance between the two. So that line disappeared. So we can't actually calculate what happens if the distance is, and now I can't move it anymore, but we can't calculate what happens if the distance is 0. So we have to look at a concept called limit. We're going to look at what happens as that distance gets really, really, really close to 0, and then we can look at changing things and finding different slopes. So let's see if I can get back. There we go. So again, we want this to be really, 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 really close, and if it's super duper close, it turns into what we call the tangent line. And that's what the whole beginning of the year is about. So secant is what you did prior to this year. Now we're moving these two close, close, close together, and we're finding the slope of this line now. So we're still using the slope formula, but now it's going to give us the slope of the tangent instead of the secant. The next thing we're going to do is we're going to talk about area. So what we're going to do is we're going to find the area under a curve. So if I said find the area from point A to point B, one method you would use in like geometry is to maybe split this up into shapes that you know. So what we're going to do is split it up into rectangles. So we're going to use the function to create rectangles, and we're going to add these together and find the area under the curve. One way to make this more accurate is to make more rectangles. So if we made even thinner rectangles, we would have a much more accurate area because we would have a lot less extra space, a lot less wasted space. The only way to have the then exact area is to have an infinite amount of rectangles in here. Rectangles that are so skinny and so narrow, their width is almost 0. It can't be 0 because then it wouldn't exist. It's almost 0. So again, we're using that concept of limit to get as close as we can to having an infinite amount of rectangles in here. And so that's what we're doing when we look at calculus. So the biggest thing is from this particular video is that you understand how to calculate average rate of change. Again, average rate of change is the same as the slope.